Hello and welcome to yet another video of Cornerstones of Math. In this video, I will show you one important and famous method to minimize the length on geometric figures. Today's problem reads like this. A sector has radius r and center angle theta, which has a value between 0 and pi over 2. 3 points, P, Q, and R, move on arc AB, line segment OA, and line segment OB respectively. What is the minimum value of the perimeter of triangle PQR? Let's try to solve this problem without using calculus. Let's get straight to the point. First, we do this. We construct additional sector that is congruent to the sector OAB, with line segment OA being the line of symmetry. On the arc of this new sector, we mark point P' that is symmetric to point P with respect to line segment OA. You can find this point by drawing a perpendicular line PH and find the intersection point between this line and the arc of the new sector. You see, if we draw additional radii like this, then by the Pythagorean theorem, you can easily notice that length PH and length P' H are both given as square root of r squared minus length OH squared. Then, because of this relation, if we connect point Q with point P', then both length PQ and P'Q are given as square root of PH squared plus QH squared. So we obtain an important length relation. PQ is equal to P'Q. Similarly, on the other side, we draw additional sector that is symmetric to the original one with respect to line OB. Next, we draw the perpendicular line PK and mark the intersection point P' on the new arc. Then, by the same logic, point P' is symmetric to point P with respect to line OB, which leads to the similar conclusion that length PR is equal to length P''R. So we have obtained these two pairs of equal length, but before we move on, let's investigate one more thing. What would be the magnitude of the angle P'OP'? Here, let this angle be alpha and this angle be beta. Then alpha plus beta is equal to theta. Moreover, by the symmetry, this angle is also alpha and this angle is also beta. So angle P'OP' is given as 2 alpha plus 2 beta, which is 2 theta. So this angle right here is 2 theta, which is constant. Therefore, we have another very important conclusion. Even though the positions of P' and P" change because they depend on the position of P, the magnitude of the angle P'OP' remains constant. Now with this additional knowledge, let us finally consider the perimeter of triangle PQR, which we will denote as L. It is given as length PQ plus length QR plus length RP. Here I have shown that length PQ is equal to length P'Q and length RP is equal to length RP'. So we have P'Q plus QR plus RP', which is this length plus this length plus this length. And you can easily notice that such combined length is greater than or equal to length P'P'. Therefore, the minimum value of the perimeter of triangle PQR is the length of the line segment P'P', and these intersection points are the positions of point Q and R that gives the minimum value. So this is the minimum case, and we need to find the length of the line segment P'P'. There is more than one way to do it. For example, if you split the triangle like this, so this angle is theta and this angle is theta, then this length is r sine theta, and this length is r sine theta, giving length p prime p double prime as 2r sine theta. Or you can use the law of cosines, which gives this length as square root of r squared plus r squared minus 2 times r times cosine 2 theta, which gives length p prime p double prime as r times square root of 2 times 1 minus cosine 2 theta. And finally, one more thing. These points Q and R at the minimum is dependent on the position of P. However, this point P can move freely, only with one constraint, that it must be on the arc AB. This means that there are infinitely many cases for the minimum perimeter. For an arbitrary point P on arc AB, all you have to do is to find symmetric points P prime and P double prime, and you can connect these 2 points with a straight line to find the positions of Q and R for the minimum perimeter. And that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.